Okay, so I'm going to put this in my calculator, and I'm going to work through actually putting these in, because sometimes it gets a little tricky with the parentheses. Okay. Come on. All right, so we are looking at 15,000 parentheses 1 plus, now I'm going to use parentheses again, 0.0825 divided by 4, close my parentheses, and then close it again. And what I was showing Jessica was when you're using parentheses, count your left parentheses and your right parentheses. We should have the same number. So I have 2 left parentheses, so I should have 2 right parentheses. And then this is to the power of 32. And I get 28,827.68. Okay. Okay. We good with that? Why I'm not able to. There we go. Okay, the next one. We have 15,000. This time it's compounded monthly. Excuse me, I'm sorry, I'm coughing. An interest rate, okay, same interest rate. So what's going to be different with this one? Instead of dividing by 4, what am I dividing by? 12, right. Oh my goodness gracious. Excuse me. And then this will be to the power of 12 times 8. Okay, so excuse me. Oh my goodness gracious. Okay, so to save time, since I already put the formula in once, dividing by 4, I will just have problems. Here we go. I'll arrow up, press enter. So now I can just go over and change this 4 to a 12. Right, and then the exponent, I'm going to do 12 times 8. And we get 28,956.42. We're talking about money, so I want to round to the 100th place, to the second decimal place when I'm talking about money, okay? Any question on that one? How'd you all do with it? Good? Okay. It's not hard, not this part anyway, once you know the formula. Okay, this time we're compounding annually. So when we compound annually, we can shorten the formula, because remember it's A equals P times 1 plus R over N to the NT. And remember, the N refers to the number of compounds per year. So because of that, the N is going to be 1. So I can just do P times 1 plus R to the power of T. Okay, so we're looking at 2,000 times 1 plus, how do I put that in decimal form? Right, 0.1325 to the power of 22. Okay, so we have 2,000 times, I'm going to just put it as 1.1325 to the power of 22. Thank you, Caleb. And we get 30,000. Thank you. $30,893.75. Are we good? Okay. Next one. Same thing, $2,000, 22 years, annual percentage rate of 4.25, compounded daily. So A equals 2,000 times 1 plus 0.0425. And what are we dividing by? 365 because it's daily. That's the power of 365 times 22. So we have 2,000 times 1 plus, I'm going to use my extra parentheses, 0.0425 divided by 365 to the power of 365 times 22. Okay. Does that sound right? $5,094.15. Okay. Questions? Okay. Oh my goodness. You can just prop it open because I think we have a couple people probably coming. Here you go, ladies. Okay. So this time we have $8,000 invested at 2% annual interest, compounded semi-annually for 9 years. All right. Same stuff over and over again, right? 8,000, 1 plus, okay, it's semi-annually. And what was the interest rate again? 2%. Okay, so that's 0.02. And what are we dividing by? 2. So the power of 2 times 9. Okay. So we have 8,000, times 1 plus 0.02 divided by 2 to the power of 18. And that gives us $9,569.18. Okay? Any questions on the first page? Okay. The second page, this is the calculator page. Okay. Okay, and this was, excuse me. Okay, so remember in your calculator, you're putting in a T. So I'm going to go ahead and put this in the calculator. Okay, so we've got 5,000. And that's going to be 1 plus 11%. So that's going to be another parenthesis, 0.11 divided by 4 because it's quarterly to the power of 4x, right? We're trying to solve for t. So when I graph this in my window, I'm going to start at 0 because X represents time, and we're not going to have any time less than 0. Y represents the amount of money I have in the account, so I'm going to start at what value? When X is 0, Y will be 5,000. So I'm going to start at 5,000. You could start at 0 if you wanted to. And I'm going to go to 15,000 because the question is specifically asking how long it will take to double, and doubling would be 10,000. So 15 will give me plenty of space. You could put 10,000 in there. Actually, I'm going to do that initially just to show you why I don't do that. And I'll go by increments of 1,000. Okay, now when I graph it, okay, there's the graph of the equation. If I put 10,000 in my next Y, okay, this is why I don't like to use that value as my maximum, because I don't like working with it at the top of the screen like that. I find it easier if we give ourselves a little buffer space. Okay. Okay, so this is what we're doing. This blue line represents the compound interest formula, which gives us the amount of money we have in the account at any given time. So the x-axis represents the time. Okay, so in 2 years, this is how much money I have in the account. Okay, the red line represents my goal money. I'm trying to figure out how long it'll take me to have $10,000. Okay, so this is when that blue line, when that equation equals 10,000, right where they intersect. So we do calculate, so we go second, calculate, and we're going to choose option 5 for intersect. It's going to default the curves. It says first curve, and you see it up here is Y1, so I'll just press enter. It jumps up, second curve, Y2, I'll press enter. And then it wants a guess. Since there's only one point of intersection, I can just press enter. If there was more than one point of intersection, I would want to move my cursor closer to that point. So I'm going to press enter, and it tells me right here the point of intersection is X equals 6.387587, Y equals 10,000. So I'm going to round this to 2 decimal places, so 6.39. So we're talking 6.39. Now what's the unit? Years, right. Okay. Okay. So the next one, we've got $6,000, and we are earning 9% interest, compounded quarterly, so we're dividing by 4 again. So to the power of 4t or 4x, and we're trying to find out when that doubles. So again, it's 12,000. Okay. Now I'm going to show you a little trick on this. We could solve it just like it is. In fact, let me do that first, and then I'll show you my trick. Okay. So let's see. First off, I want this to equal 12,000 instead of 10. Okay, my equation is 6,000 times 1 plus 0.09 divided by 4 to the power of 4x. My window should be okay. Okay, so there's my graph. And if I calculate intersection again, first curve, second curve, guess, I get 7.7879, so I'll round that to 7.79. Okay, 7.79 years. Okay, now here's a little trick that you can use sometimes. Notice if I divide by 6,000 on both sides before I try to solve the equation, I'm going to get 2 equals 1 plus 0.09 over 4 to the 4x, right? Now notice it said, how long does it take to double? And I ended up with a 2 over here. Well, doubling means 2 times the amount, right? If you look at this equation in the form that it is, there's no number in front of the parentheses, which means that P is actually equal to 1. What is 1 doubled? 2. So if I put it in the calculator in this form, instead of using the 6,000 and the 12,000, delete that, and then just leave this as a 2. The nice thing here is that I don't have to worry about my window now. Okay, so the other way you have to adjust your window based on the values. Here I can just use a standard window and I can see my point of intersection. If I do a calculate intersect, I get the same value. So the advantage of doing it this way is that I don't have to fuss with the window. If it said how long would it take to triple my $6,000, what would that equation look like? It would be 3 equals 1 plus 0.09 over 4 to the 4x. Okay. If it said how long until it's 10 times, it would be 10 equals. Okay, does everybody understand that? It does make the graphing easier, but you'll get the same answer regardless. Okay. What did you get? 11.6. Let me come look. I think it was 0.09. Okay, last one. So again, we're looking to see when it doubles. So we've got 6,000 times 1 plus, it's 6%, 0.06, compounded quarterly. So what am I dividing by? 4 to the power of 4x. And this wants to equal 12,000. So I think you skipped a problem again. I think that's what happened. Again, I could divide both sides by 6,000 and solve the equation like this. Okay. And just because I already have this one set up the way it is, I'm going to do that. All I have to do is change that to a 0.06 instead of 0.09. Okay. Graphing it. Okay. Obviously now I can't see the point of intersection because it's happening over here. So I do have to adjust my window. So I'm going to go, x is going to go from 0 to 15. Okay, now I can see my point of intersection. And I get 11.64. Did anybody do it the other way, using the 6,000 and the 12,000? Did you get 11.64? Okay. Okay. I'm going to stop there. Do we have any questions? Okay, I'm going to give you a quiz. It's a short quiz. 3 questions.
Do you want us to still run it into Google Classroom?
Yes, but let's do it after the quiz, okay? That way we won't run out of time. That's if I can find your quiz. There it is. Just 3 questions. Make sure you write out the formulas for me. Okay. Yeah, or you want to take it in the morning, or you just. Okay, I need you guys to take it tomorrow though. Okay? Preferably in the morning. Oh, wait a minute. Shoot. What's tomorrow, Thursday? After school, but I have a meeting at 1, so it needs to be before that. Yes. Okay, now or tomorrow?